I'm Anil Kumar. Welcome to my series on trigonometric functions. Now we will discuss three very important optimization questions based on trigonometric functions. I have given the diagrams with the questions also so that you can really understand and solve these questions on your own. Take time to copy these questions, solve, and then look into my suggestions. Now let's discuss. Question number 1 here is, a thin rigid pole needs to be carried horizontally around a corner joining two corridors, which are 1 meter and 0.8 meter wide. Calculate the length of longest pole that can be carried around this corner. So we are given this corridor. One of them is 1 meter, the other one is 0.8 meters, and that is the length of the pole, right? So if you say that this is angle theta, that has to be angle theta also. Now you can find the maximum length of the pole using trigonometric functions, correct? Now this length is combination of these two. You can define those as x and y, write them in terms of the given dimensions and differentiate to get the answer, correct? Question number 2. Distance between the hockey goal post is 6 feet. So let's say this is the hockey goal post, right? So this distance we are taking 6 feet. If Sidney Crosby is on the goal line 3 feet outside, that is 3 feet outside the goal line of one of the posts, how far should he go out perpendicular to the goal line? That means this distance. So we are taking this distance as x, right? To maximize the angle in which he can shoot at the goal. So that's the angle theta in which he can shoot at the goal, right? When the diagram is before you, it's kind of simpler to understand the question and solve it. But in the test, you may not get this diagram. So try to think how you can visualize the situation, make a diagram, and then solve it, right? Question number 3 here is, a tool shed 250 centimeter high and 100 centimeters deep is built against a wall. Calculate the shortest ladder that can reach from the ground over the shed to the wall behind, correct? So that is the ladder. So let's call the length of the ladder is L. This is the shed, which is 250 centimeter high. So that height is given to us as 250 in centimeters and 100 centimeters deep. So that is 100. Is it okay? And that's the ladder. So these are 3 questions for you. Try to solve them. They'll help you to understand most of the concepts. Now let's look into the solution of question number 1. A thin rigid pole needs to be carried horizontally around a corner joining two corridors, which are 1 meter and 0.8 meter wide. So let's say this is 1 meter and this is 0.8 meters. Calculate the length of longest pole that can be carried around the corner. So that's the corner we are looking into, right? So let's say that the length of this pole is L. Now in this particular case, what we can do is we can think about the angle made by the pole as theta, and we can write L as combination of these two lengths. So let me call these lengths as x and y. Okay, so we can say L is combination of x and y. Now what is x equals to? If this is theta, so we can say in this triangle sine theta is equal to 0.8 over x, and that gives you x is equals to 0.8 over sine theta, correct? Now similarly, in the smaller triangle we can write since we are given the adjacent side, it's good to write in terms of cosine theta, correct? Which is 1 meters over y. So that gives you that y is equal to 1 over cos theta, correct? So now we can write what length L is in terms of sine and cosine. So L is 0.8 over sine theta plus 1 over cos theta. To maximize, we need to look into the first derivative. So let's find derivative of this function with respect to theta, since theta is our variable, right? So basically we have written length as a function of theta. Do you see that? So we can differentiate both sides with theta. So we get dl d theta equals to. Now here we'll apply the quotient rule. So we get sine square theta in the denominator. Derivative of sine theta is cos theta, but with a negative sign because this is to the power minus 1. 0.8 cos theta, correct? And here we get cos square theta. So minus, because when you take this, it is to the power of minus 1, right? And derivative of cos theta is minus sine theta. So that's what you get. Now for the critical number, so let's find the critical number. For the critical number, L dash should be equal to 0. The derivative should be 0. That is to say, now the whole thing should be equal to 0. So we'll quote this as equal to 0. Let's take common denominator, which is sine square theta times cos square theta. When you cross multiply, we get minus 0.8 cos cube theta. That minus minus becomes plus sine cube theta. Correct? Now to solve further, let me take it to the right side. We have some space here and then work it out. So for the whole expression to be 0 on the right hand side, the numerator should be 0, right? So what do you get? Taking one of these terms, this is negative, that is positive. I could write this as sine cube theta equals to 0.8 cos cube theta. Now we'll divide both sides by cos cube theta. So we get sine cube theta over cos cube theta equals to 0.8. And so that is tan cube theta, right? So tan cube theta equals to 0.8. And that gives you tan theta equals to cube root of 0.8. So theta equals to tan inverse of cube root of 0.8. So you can use the calculator. Set your calculator in radians. Well, this particular question you could do in degrees also, but whenever you're working in trigonometry, make sure that your calculator is in radians, right? Now let's find tan inverse of cube root of 0.8. So that gives you the value of theta as 0.7297, right? Now, this gives you a maximum or not. How do you decide that? Well, we could look into two conditions. One is that you could take a rod which was like kind of vertical. In that case, length is 0.8. You could take a rod which is kind of horizontal. In that case, length is 1 meters. So if our answer is more than 1 meters, that is maximum. Is that okay? So those are the two limits. With that, we will check the value now, right? So what do we get here is theta to maximize or to minimize, you can say, is this, right? And this is in radians. Okay. Now, let's figure out how much it is. We'll just substitute the value and calculate. So length is x is 0.8 over x, which is 0.8 over sine of theta, which is sine of this value, 0.7297 plus 1 over cos of 0.7297. Is it okay? So we'll just calculate this value. So we have 0.8 divided by sine of 0.7297, which is equal to 1.2, plus we have 1 divided by cos of 0.7297, which is equal to 1.34. So when you add them up, you get 2.54 as your answer, right? So the maximum length, rod length in this case, is 2.54 meters. Is that correct? Since it is more than 1 meters, we'll say this is maximum length, right? So now let's move on to the next question. Question number 2. Distance between the hockey goal post is 6 feet, so that's the distance between the hockey goal post. If Sidney Crosby is on the goal line 3 feet outside one of the goal post, how far should he go out, that means in this direction, perpendicular to goal line, to maximize the angle in which he can shoot at the goal? So that's the angle theta which we want to maximize. Now this is really a very interesting question, and you have to use knowledge of exterior angles to solve this kind of question. So let's try to understand. So let us say that we have to relate this theta. You can actually use cosine law also, but what we will do is we'll say let these two angles be alpha and beta. Let me call this as alpha, this as beta, that is theta, right? So the exterior angle beta is equal to sum of these two angles, alpha plus theta, right? So that gives you that theta is equals to beta minus alpha. Does it make sense to you? Right, so we'll follow the angles rather than finding a side. You could actually find the sides, apply cosine law also, and solve this question. Is it okay? You can do that. Now, well, what we did was we just related this angle with all this, theta. Now, what is tan theta equals to? So let me write down. Tan theta could be written as tan of theta is beta minus alpha. Beta minus alpha. Do you see that? And you know the compound angle formula? You could expand this as tan beta minus tan alpha over 1 plus tan alpha tan beta. Perfect? Right? Now what is tan alpha and what is tan beta? Let's look into this diagram once again. Alpha means opposite side over base, which is 6 plus 3. So the total length here is 9, correct? So tan alpha is, we can write here first, tan alpha is x over 9, and tan beta is the smaller triangle, x over 3. Right? So replace these values here, and so we get tan theta equals to x over 9 minus, this is beta is x over 3. So this is 3, and this is x over 9 over 1 plus x over 3 times x over 9, correct? Now taking common denominators as 9, I could write this as 3x minus x divided by, we took 9 as a common denominator. Here common denominator is 27, so we get 27 plus x squared over 27, right? Now this could be written as tan theta equals to 9 and 27 you could cancel 3 times. So divide means it comes on the top. So we get 3 times, within bracket 3x minus x is 2x, and in the denominator we have 27 plus x squared. So I hope it's absolutely clear up to now. So what we've done here is we have written in terms of x, this expression. We'll now differentiate both sides with respect to x. So what do we get? Derivative of tan theta is secant square theta times d theta dx. And here we are going to apply the quotient rule. So we get 27 plus x square whole square. This is 6x. Derivative of 6x is 6. 6 times 27 plus x square minus 6x times derivative of denominator, which is 2x. And for a critical value, this should be equal to 0, right? For critical number. First derivative should be 0, right? So now we'll find x value for which the critical number is achieved. That means the numerator is 0. Is that okay? So now we'll just solve the numerator. We can take 6 common. That should be 0, right? So we have 6 common. We have 27 plus x square. And here 6 common. So we get 2x minus 2x square. We took 6 common. Correct? That should be equal to 0. So that means 27 minus x square is equal to 0, or x is equals to square root of 27, right? So that is the value of x. Square root of 27 is equal to 3 square root 3 in decimals is 5.196. 5.196. So all are in feet, right? All are in feet in this case. To maximize the angle, x is equals to, you can say approximately 5.2 meters. Perfect. So that is how you can actually solve this question. Now, whether this is a maximum or not, how do we figure this out? Well, right hand side, it reduced to how much? 6 was common, right? 6, and within bracket we had 27 minus x squared. So let me write down 6 times 27 minus x squared, and the denominator is 27 plus x squared whole square, correct? So we can take a critical, this is our critical number, right? So this is our critical number, which is 5.2 meters. So let's find the, if I take a value which is, let us say on the right side, if I take a value which is 6, and on the left side we take a value on 4, correct? So if I substitute in this value, basically only this value is to be checked. So if I substitute a value 4, I get positive. Do you see? This is positive. So we are analyzing secant square theta. Secant square theta is always positive. Perfect. This is always positive. And we are analyzing d theta dx. Let me write d theta dx. So if I substitute 4 here for x, I get positive value. And if I substitute 6, then x squared is 36. You'll get a negative value. Right. So analyzing the first derivative, we can ensure that this value will give us a maximum angle. That's the important part, right? Okay. So I hope that's absolutely clear. Now let's move on to solution of question number 3. Question number 3. A tool shed 250 centimeter high and 100 centimeter deep. So that is the tool shed, 250 centimeter high, 100 centimeter deep, is built against a wall. So that's the wall. Calculate the shortest ladder that can reach from the ground over the shed to the wall behind. So let's this be the shortest ladder. So as we have done in most of our questions in similar kind, we'll split this length into two values, which is x and y, and we'll keep this as theta. Perfect. So I hope now it is very clear how to solve it. I'd like you to actually pause the video, answer this particular question, and then look into my suggestions, right? So here we can write L equals to x plus y, but what is x and what is y in terms of theta? Now in this diagram, you will notice that this length here is 100 and that height is 250, right? So this height is 250, correct? That should help you to figure it out. So from here, it is very clear that if I consider this triangle at the base, then relating opposite side to hypotenuse, I have to write sine theta, right? So sine theta is 250 over x, or x is equals to 250 over sine theta. Perfect. As far as y is concerned, we'll use the base as 100. So we can write this as cos theta, the adjacent side, over y, the hypotenuse. That gives you y as 100 over cos theta, correct? Okay. So we could write length L as equal to combination of these two, 250 over sine theta plus 100 over cosine theta. And the derivative with respect to theta will give us dl d theta equals to, what is the derivative of this? Now I'll use the standard technique which some of my students use. They write sine theta as sine theta to the power minus 1. So I'm going to use that exercise now. It helps, right, to do questions in different ways so that, you know, all are familiar with what you're solving. So now the derivative could be written as applying the power rule. We get negative of 250 times sine theta, right, to the power of minus 2 times derivative of sine theta, which is cosine theta. Perfect. Here we get negative 100 times cos theta to the power of minus 2 times derivative of cosine theta, which is minus sine theta. Perfect. So that gives you, so that minus means it brings it down. So we get minus 250 over sine square theta times cos theta. And here minus and minus makes it positive. And we have 100 sine theta in the numerator over cos square theta. So I hope that this step makes it clear how we did earlier, right? We directly wrote this using quotient rule. So this time, instead of quotient rule, we rewrite this and use the power rule. Okay, rest is all same. So dl d theta is this, and we want to equate it to 0 for critical number, right? So let me take common denominator as sine square theta times cos square theta. We get minus 250 cos cube theta plus 100 sine cube theta. So since that is to be 0, the numerator should be 0. Perfect. So let's do that. So we'll make the numerator as 0. That means 100 sine theta, sine cube theta, should be equal to, bringing it to the other side, 250 cos cube theta. Dividing, we get tan cube theta equals to 250 over 100. So theta equals to tan inverse of cube root of 2.5. Is it okay? So that is the value of theta this time. Theta is tan inverse of cube root of 2.5, which is equal to 0.935, let me write 8, right, radians. So ensure that your calculator is in radians. You can use degrees, but that will be discouraged. In calculus, as you know, the limit of sine theta over theta is valid only in radians, not in degrees. So always work in radians. Perfect. Okay. Now, we know this is shortest. Why? Why? Can you tell me? So it is shorted because, one, we have two different conditions. That is to say, we could have a vertical rod, right, which will be infinitely long, correct? Or we could have a horizontal, which will be infinitely long. So whatever is the answer is the shortest. That is the logic which I'm going to give for this particular case. Perfect. And now we'll just calculate the value, which is L equals to 250 over sine of that angle, which is 0.9358 plus 100 over cos of this angle, 0.9358, correct? So that is equal to 250 divided by sine 0.9358 equals to 310.5 plus 100 divided by cos of 0.9358, which is 168.58. Let's add them. 310.5. So we could write this as 479.08. Okay. So around 479 centimeters. Is it okay? So we get our answer as 479. The units are centimeters. So the maximum length answer is, the shortest is 479 centimeters, or you can say 4.8 meters if you want to, right? So 4.8 meters is the shortest length. So I hope with this set of 3 questions on optimization using trigonometric functions, you are comfortable solving similar questions for your test. Feel free to write your comments, share your views, and if you like my videos, and share them with your friends, that'll be very good for me. Thank you, and all the best.